In the last lesson, we introduced the Columnstore index and talked about the technology it uses and what we might do with it. So let's look at it hands-on and actually take a look at how it works. In this database, I have a fact table called Fact Flight. This table contains a record for every domestic flight in the U.S. over the last around 10 years or so. And if I look at the storage settings, I can see I have about 11.2 gigabytes, around 140.7 million rows. This table happens to be an unindexed heap. It has no clustered index. It has a lot of foreign keys, and its structure is pretty typical what we'd see in a data warehouse, with a number of foreign keys to dimension tables and a lot of measures. One thing we might want to do with this kind of data is summarize it. So this query that we have here is going to summarize the flight distance miles for flights by year by carrier, and we are doing inner joins to bring in the carrier name and the date dimension to make it look nice and pretty. So the first thing that we're going to do is to run this query, and essentially this is going to cause a brute force table scan of the table and give us output by year and carrier with the sum of distance miles. So we're just going to run that and wait for that to run, and I'll get back with you when it's finished. The query is completed. It ran in about 1 minute and 7 seconds, and we can see in our output we have the year and the carrier, the miles. I didn't order it, but I can see that I have all the rows I'm looking for. Now, just to keep the fight fair, we're going to run this a second time so that SQL Server can take advantage of anything that it has in RAM at this point. So I'll just run it one more time and see how long it takes for the second run. The second run is complete, and it took 1 second less. So really, the RAM caching of data for this query didn't do much good. Now I'd like to compare how long would that same kind of query against this fact table take if I had a Columnstore index. So let's create one. So here's the statement for creating that Columnstore index. It's very similar to a create index statement. We just add non-clustered column store on table, and we're going to include all of the columns in the table. For the query I'm looking at, I don't really need all the columns, but I'm going to do this anyway because then any query that I run against this table that has a Columnstore index is going to perform very well. Let's go ahead and run this. Our Columnstore index is built. That took 7 minutes and 53 seconds. So let's look first at how big is that index. So we have a query here, which we can run to determine the size of our Columnstore index, and essentially it's going to go out and query the system tables for the index type of Columnstore and add up just how much is that going to use. I'll just execute this query, and I can see that my Columnstore index is about 3.5 gigabytes, and that's on top of the roughly 11 to 12 gigabytes that I already had in the table. So there's a fair amount of disk used here. Let's see whether that disk usage is worth it. Let's go back to our query for the flight table, and first I'll just run a execution plan to see whether that index is going to be used in this query. And if I scroll down, I can see that there are a couple of tables in this query plan. So there will be a scan of the carrier table here, and I'll have a scan of the date table. Those are fine. When we're scanning the flight table, though, we don't see the table itself anywhere in this plan. We see a scan of the Columnstore index. And then after that index is scanned, we get our hash matches and so on to get output. So we're not going to hit the table, we'll just hit the index. Let's execute and see how long that takes. So we've queried out our data. That took 3 seconds. If I run that again, 2 seconds. So we've reduced our query time on this query from 1 minute and 7 seconds to 2 seconds. So that's our Columnstore index. So we've taken our 140 million row table, created a Columnstore index, and that's dropped this table scan query from 1 minute 7 seconds down to 2 seconds.